at averages. Okay, so today's learning objectives, we're going to be looking at how to calculate the mean, the median and the mode. Okay, and how to use them as appropriate to compare sets of data. Okay, we're going to look how to calculate the range and use this as appropriate to evaluate the consistency of data. Okay, we're going to look how to calculate the mean or estimated mean from group tables and frequency tables, and then know that in order to calculate this estimated mean, we need to be looking at the midpoint and so on. Okay, so we're going to start off by looking at the different averages. So we've got the mean, the median and the mode. Okay, each one has a different meaning, has a different calculation. Each one has a different use, which we're going to come on to afterwards. Okay, the mean is the one that people use the most. So when people say the word average, they tend to be talking about the mean. This is the one where you add up all the data, okay, and then we divide by how many values there are. Okay, so this is the one that we tend to use the most. The median is the middle number. So it's the number that is in the middle of the set of data once we've put it into order. Okay, which we'll come on to in a bit more detail afterwards as well. The mode, nice and easy, it's the most common. It's the one that occurs the most within a set of data. Okay, this is the only one where you can have more than one answer as well. So if there's two numbers that appear 3 times within a set of data, then both of them would be considered the mode. Okay, if the data doesn't have a mode, we could say that it doesn't have a mode, or that every single one is the mode, as none occur more than the others. Okay, so you can argue either way. So to start with, nice and straightforward, the mean. So the mean, like we said, is the one where you add up all the data. So in terms of this example, we have the mean broadband speed. So we would add up all these broadband speeds, okay, which would end up with 57.5. We'll then divide it by how many pieces of data we have. So 1, 2, 3, 4, 5. So we divide it by 5 and we end up with 11.5 megabytes per second. So this number is the average. It's the mean average of this set of data. So like we said, the average, it's basically a number that represents the data. It's roughly going to be within the middle of the data. So if we look, we've got 6.7 as the smallest and 17.1 as the biggest. It's going to be within the set of data, hopefully somewhere in the middle. Okay, so that's how we know that we've got a sensible answer. So here we've got some data again. We've got the average temperature in Nice. So we want to work out the average temperature in Nice. So we'd add all this together. So 24, sorry, add 23, add 24, add 26, add 27 equals 124. Let's just double check that. So 24, add 23, add 24, add 26, add 27 gives us 124. We then do 124 divided by 1, 2, 3, 4, 5 divided by 5 gives us 24.8 degrees. And if we look, it's a sensible answer. It's within the data, so we know we've got it correct. Okay, Enid owns a coffee shop. Her coffee shop is open for 6 days a week. Enid wants to find the average sales from each of her coffee shops. The table gives the information about the coffee sold in her coffee shop in London. We want to work at average cups of coffee sold by Enid. So 225, add 188, add 208, add 241, add 222, add 320. The reason I'm writing all this down is use the box clearly to show how you get your answer. So even if we don't get the right answer, we still get marks for showing us using the right technique and the right method to get there. So we add all these up and it gets 1404, and we divide by 1, 2, 3, 4, 5, 6. Divide that by 6 will give us 234 cups of coffee. Okay, show a check from your working. Okay, this is where people lose marks because it's a simple thing to overlook. Okay, so show a check. Doing this alone, getting the answer will probably get us 2 marks. This show a check will give us the extra mark. Okay, it's easy to miss out, it's easy to miss these marks. So, in terms of a level 2 exam, what they want you to do is just do the inverse. The inverse method is basically do it backwards and opposite. So 234, if we've done this correctly and we multiply by 6 instead of divide by 6, we should end up with 1404. So we know we've got that stage correct. And instead of adding all these numbers, we can take them all away. And if we've got it correct, we should end up where we started at 0. And that's how we show a check. We do it backwards and opposite. It's called the inverse method. So that's the mean average. Nice and straightforward. Now we're looking at the median. So the median is the middle number when you put the data into order. So here we've got a set of data. They've popped it into order for us. Okay, there is a way of working out which number it is, and I'll show you both methods. So in terms here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sets of data. So 11, what we do is add 1, which is 12, divide by 2 is 6. So we're looking for the 1, 2, 3, 4, 5, 6th number in this set of data. So you add the numbers up, how many numbers you've got in your data, add 1, divide it by 2 will tell us what number in this order that we need to look for. Okay, another method is just we can go 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and we've got 1 left in the middle. Either method is entirely up to you. Here we've got another example. So a bookshop records the amount of money that customers have spent in the last 10 customers. We put them in order. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 plus 1 is 11. Divide by 2 is the 5.5. So it's the 5.5th number, which means that we end up with two numbers in the middle, number 5 and number 6. We're looking for the number that is in the middle of these two. So we add them together. 35 plus 41 is 76. And then we divide by 2 to get 38. So 38 is the median. Even though it's not in the data, it is the median. And again, 1, 1, 2, 2, 3, 3, 4, 4 leaves us with 2 in the middle. So we're basically looking for the middle of the middle. Okay, that's when we have an even set of data. If we have an odd set of data like we've previously done, there'll just be one number in the middle. Right, so we put these numbers in order. So 9, we can cross them out just to make sure we don't make any mistakes. 9.5, oh, and then nicely these are all in order for us. So 10, 10.5, 11, 12, 15, 23, 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 1 is 9, divided by 2 is 4.5. So we're looking for the 4th and the 5th number. Because there's an even set of data, it's going to be 2 in the middle. So we add these together to get 21.5. Divide by 2 will give us 10.75 as our answer. Okay. Right, so this one is a 4 marker, so it's a little bit more complicated. So Josh is a product designer for an electrical company. He designs a new table lamp. Kirish works in the finance department for the company. He has this information of prices of similar lamps. Kirish needs to set the price of the lamp for Josh. He will set the price at 5/4 of the median price of 6 similar lamps. What price should Kirish set? So we ignore the fraction to start with. We need to obviously work out the median. So we put these in order. So 25.5, 27.9, 1, 2, 29.6, 33.8, 36.4 and 41.5. 1, 2, 3, 4, 5, 6. 6 plus 1 is 7. Divide by 2 is 3.5. So looking for the 3rd and the 4th number. Right, so 29.6 add 33.8 gives us 63.4. Divide by 2 will give us 31.7. So the median price is £31.70. Okay, but we still need to set the price at 5/4 of that price. So if we remember back from fractions, if we have a fraction, no matter what it is, and we want to work out a fraction of something, we divide by the bottom, and then we multiply by the top. So 31.7 divided by the bottom number, which is 4. So we divide it by 4, and then we multiply by the top, which is 5. And we end up with 39.625. But in terms of money, there's always 2 decimal places. So 39.63 as we're going to round. Okay, so hopefully that made sense. So we've worked out the median. We've got the median as this. We then want to set it as 5/4. So we divide by the bottom, times by the top, and that is now our answer. Okay, the mode. I'm not going to spend too much time on the mode. It's straightforward. So the mode is the most common value. Mode, most. The way I always remember it is the mode, most, median, medium, the middle number. So it's the one that occurs the most. So you could, like they've done here, put them in order because it puts them all in groups. But why waste 30 seconds of your life? We can just look. So here, there's 3 9s. I can see that. If it's a big set of data, yes, put them into order. If it's not, just look. So here, find the mode. We could spend 30 seconds putting them in order, or I could go, there's 3 11s, so the answer is 11. Okay, nice and straightforward. If there was another 8 in this set of data, we would also have 3 8s, which would mean that the mode is 11 and 8. We wouldn't do anything fancy, we would just go 11 and 8. Right, the range. The range is not an average, but it is a data comparison. Okay? So sometimes when you're dealing with a set of data, you may be asked to find the range. The range is not a type of average, but it is another way to summarise a set of data. It's basically the biggest number, take away the smallest. Okay? But it does tell you a lot about the data. So here we've got an example. So babies are weighed when they are born. The weights are those. Find the range of it. So again, we can put them in order, so we can definitely see which is the smallest and biggest. Or we could just look. 4.1 is the biggest, 2.2 is the smallest. Biggest takeaway, smallest, gives you the answer. That is it. Right, here we've got the average temperature in Nice again. Biggest takeaway, smallest. So 27 takeaway, 23 equals 4 degrees Celsius. But what does this tell you about the data? Okay, the range here is very small. It's a very small number. It's 4 compared to the numbers here. If the number is small, it shows that the data is consistent. It's going to be roughly the same if these years were going to continue. So if you were going to Nice and the range was only 4 degrees, you know that the temperature is roughly going to be in the 20s. Okay, because the range is small, the data isn't going to differ too much. If the range was 20, it would mean that the temperatures can differ vastly. So you wouldn't know what to pack. You'd pretty much have to pack everything. Whereas if the range is small, you're going to know it's going to be quite warm. You know what to wear. You know what to pack. Okay, so the bigger the range, the less consistent the data is. The smaller the range, the more consistent it is. So here we've got bank employees and their monthly wage. He wants to work out the median and the range. So the median, we'll put them in order. So 1600, 1600, 2400, 2500, 2700, 7500, and then 1, 2, 3, 4, 5, 6. So we're looking for 6 plus 1 is 7. Divide by 2 is 3.5. So the third and the fourth. So we add those together, which is going to be 2400. Add 2500 is 4900. Divide that by 2, and we're going to get 2450. So the median is 2450. Okay, the range is going to be the biggest, so 7,500. Take away 16, which is going to be £5,900. Again, what does that tell you about the data? It tells me that the difference between Big Boss Man up here and the guy down here, that the difference is vast. The biggest earner is earning £5,900 more than the person that earns the least. So this data is vastly spread. Okay, that's what it's telling me about this data. Right. The table below shows the valuations for houses in the same street. Work out the mean. So let's add all these together. So I'm going to go 120, add 125, add 118, add 525, add 122. Gives me 101,000. So 1,010,000. Okay, then I'm going to divide that by 1, 2, 3, 4, 5. Divide it by 5 gives me £202,000 as the mean. Okay, so I've added them all up, divided by how many there are? 202,000. Okay, so what is the problem with using the mean here? Okay, so let's have a look at the answer, 202,000. Let's have a look at the data. 120,000, 125, 118, 525, and 122. So, what is the problem here? Well, like I said, what is the point of an average? The point of an average is to represent the data roughly somewhere in the middle. This is roughly in the middle of this data, but does it represent the data? We've got 4 numbers in roughly 120,000, and we've got one number, so it's 525. So this is what's called skewed data. If I just use a number line as an example, 4 of these numbers are here, one of these numbers is up here. It's an outlier. This massive number is an outlier because it lies outside of the data, so we call it an outlier. Because of this outlier, this mean has been skewed up here, pretty much in no man's land. It's in the middle of nowhere, so it's not representing this lower data, and it's not representing this higher data. Okay, so if this question were to come up, I would say that the data has been skewed by the outlier, by the 525,000. The same would happen if we had a house that was worth like 50,000. It would skew the data lower. Okay, so you need to be aware of outliers within a set of data when using the mean. Would it be better to use the median or the mode? Well, let's have a look. There isn't a mode. Okay, so we can't use the mode. But again, the mode may be skewed by bigger numbers. The median, on the other hand, doesn't take into account outliers. So if I just get rid of this, erase, put the pen back on. So I've got 118, 120, 122, 125, 525. Okay, outliers are always on the outside of the data, whether it be high, whether it be low. The middle value is always going to be in the middle of the data, so it doesn't take into account these outliers. So it's going to be 122, it's in the middle, 122,000 is the median, and if we look, that's better representative of this data. Okay, so hopefully that makes sense. Right, we're going to look at the range now. So the range is going to be 525,000, take away 118,000, and that's going to come out at 525, take away 118, 407,000. So I've just got rid of the zeros because it's going to take me longer to put them in the calculator, but then I'll just put them back on the end. So 407,000. What does this tell us about the data? Well, it's a massive number, so it's telling us that the difference between the biggest house and the smallest house on this street, there's a massive, massive, massive difference. Okay, so that's what the range tells us. The bigger the range, the more inconsistent the data is. The smaller the range, the more consistent. Okay, so grouped data tables. So this is a group data table. Okay, the way we can tell that is our number of pets here is a group, it is a range of data, so 0 to 2, and there's 9, 3 to 5, 3, etc. We may have a question, it comes up in pretty much every exam that I've seen, one of these questions, and they're usually 3, 4, 5 marks. Okay, follow the steps and it's pretty straightforward to get it. So the problem is when they ask for the mean. So the mean is the average, the average number of pets that someone owns. With these types of tables, we don't have exact data. So 0 to 2 is 9 people. So 9 people have 0 to 2 pets. We don't know exactly how many pets they have though. Do they have 0? Do they have 1? Do they have 2? Which is why it's an estimated mean. We always have to estimate it. Okay, so here we've got an example. So Jane helps Kai to decide the best SIM deal. She needs to know how much he uses his current phone. So here's the data that they have. If they're nice in the exam, they will give you 2 extra columns. If not, then we just make our own. We just draw them on or put them into the box, into the working out box. So the first thing we do is work out a midpoint. So we're going to estimate, so number of minutes, 0 to 10. We're going to say that the midpoint is 5. Okay? We do that by adding them together, dividing by 2. A bit like the middle numbers for the median. We add them together and divide by 2. So now we're going to estimate that the length of call is 5, because it's the average. 10, 15, etc. So we've got the midpoint. The next, because it's the mean average, we add them all together and divide by how many there are. So the number of calls was 2 for roughly 5 minutes each. So we multiply these together and we end up with 10. So that's 10 minutes in total. 60, 125, 280, 180, 110, 130. So we work out the midpoint. Midpoint multiplied by the frequency. So these columns together. So we want to work out how many minutes he has spoken for on the phone altogether. So 10 minutes plus 60 plus 125 plus 280 plus 180 plus 110 plus 130 gives us 195 minutes in total. The number of calls were 2 plus 4 plus 5 plus 8 plus 4 plus 2 plus 2, which is 27. So 27 and 895. So remember the mean, we add them all up and divide by how many there are. So we've worked out the number of minutes divided by the amount of phone calls. So 295 divided by 27 gives us 33.15 minutes. So his average phone call was 33.15 minutes. And if we look, that is pretty much in the centre of the data. So we know we've got it correct. This is the formula. It's a bit scary when we look at it, but it's basically this E is the sum of. So the sum of fx or fm, frequency multiplied by midpoint, divided by the total of the frequency. So we work out the total of the frequency times the midpoint and we divide it by the amount of calls, or the frequency in this instance. Okay, so we'll do this one as our last one. So we work out the midpoint first. The midpoint is we add them together and divide by 2, which is going to be 16, 21, 26, 31, 36. And sometimes you can see a pattern emerging, so you can do it. On some of them that I've seen, sometimes these aren't the same gap on each of them. I saw one exam which is 50, 100, 150, which can get confusing. So then we do midpoint times frequency. So 9 times 16 is 144. 3 times 21 is 63. 2 times 26 is 52. 31 and 5 times 36 is 180. I've also seen these types of questions in non-calculator, so you just need to make sure that your division and your multiplication non-calculator is on point. Okay, because there is quite a few multiplications here. Then we've got some adding, so 9 plus 3 plus 2 plus 1 plus 5 gives us 20, and then 144, add 63, add 52, add 31, add 180 is 470. So we've done multiplication, we've done adding, now we need to do dividing. So it's the total of this column, so 470 divided by 20. If we did that without a calculator, so 470, bus stop, 20. So 20s into 4 is none, remainder 4. 20s into 47 is 2, remainder 7. 20s into 70 is 3, remainder 10. So we put a decimal, 0, 10. 20s into 100 is 5. So the answer is 23.5. So the average age of everyone in this snooker club is 23.5. And if we look, yeah, it's going to be roughly in the middle, maybe a bit towards the top because it's quite top heavy in this instance. So that is working out an estimated mean from a grouped data table. So hopefully you found this session useful. Okay, hopefully you've learned the difference between the mean, the median, the mode, the range, why we would use them, what the difference is between them in certain circumstances, and then how to work out estimated mean from group data tables as well. Okay, so the next steps, okay, log on to SharePoint, download some of the worksheets that go along with this presentation, have a go, send them across to your tutor or to me, and I can get them marked for you and give you some feedback. Hope you enjoyed this session, guys. Thank you very much, and I will see you soon. Thanks. Bye.